Okay, thanks, Dave. I'm really excited today to be able to present to you this talk on common substrate for enabling solutions, Kubernetes, the POSIX of distributed systems. Before we get started, I'd just like to introduce myself. My name is Alex Jones. I'm the engineering director here at Canonical for Kubernetes. I run the Microkates team and the Charmed Kubernetes team, and we also think a lot about our cloud images that are running underneath other vendors' Kubernetes, such as GKE, AWS, etc. We try to make Ubuntu as good as it possibly can be for those platforms too. So we have an exciting remit, and today I want to share with you some reflections on where the industry is headed. And in particular, I want to look at the usage of Kubernetes as a substrate, how end users are now adopting and changing their usage of it, the complexity behind scaling out an organization, growing a business on K8s, specialization where we're starting to see opportunities and areas that are starting to become emergent trends. And we'll talk a little bit more about that later on. I hope that you come away from this feeling as if you understand that Kubernetes is now becoming particularly complex because of additional requirements, more than just deploying your first WordPress app. And that's really nice because that segues into why do we need operators? And this is particularly pertinent now more than ever, now that we have multiple clusters running across multiple clouds with very complex infrastructure. So let's take a bit of a step back and just think about where is K8s at right now. Looking at last year's CNCF report, I really picked out this piece here. Kubernetes has crossed the adoption chasm to become a mainstream global technology. And this is backed up by the fact that K8s is effectively an API and there are varying implementations. What I like to think of is that Kubernetes is like POSIX in a way. It's an interface, and you can implement under that interface. If you're not familiar with POSIX, it's the Portable Operating System Interface. And you can build towards that on Unix/Linux-based systems to give a level of consistency across different implementations. And this is useful. So if I wanted to run a thread library, if I wanted to call a thread from the standard CLib, I know that I would call it the same way across all these different operating systems. In the same vein, I know that with Kubernetes, if I want to create a pod, that pod can be created the same way with the same piece of YAML, regardless of whether it's on Charmed K8s, Microkates, or any other implementation available on the cloud. They all meet to implement that API definition. So this is one of the reasons that it's become so incredibly powerful and incredibly popular, is that it is an API specification that is being constantly evolved, but also is being joined by vendors to create effectively vendor-neutral API solutions so that their end users can interact with their products. The one that comes to mind most of all to me is OpenTelemetry, which is a combination of several other sub-projects, such as, you've got effectively the open tracing, and you have metrics, etc. And they came together in a singular API definition to help enable their end users, and the cloud and other vendors, ISVs, have come together to then offer different services on top of that, which is excellent. As I said, Kubernetes has reached that point where it's become ubiquitous throughout the ecosystem. And this is just a staggering number that 96% of organizations in technology who attend KubeCon are evaluating or using Kubernetes in anger. What's interesting is this diagram illustrates a very simple, naive attempt to use Kubernetes. And this is where a lot of folks start. You have your Spring application. You want to migrate that into a container. What do? You make a Docker image. You wrap that in a deployment. You deploy that thing out. Suddenly you realize you need storage, and maybe you need to interact with some external APIs. Maybe you hard code them into a config map or a secret, and maybe the storage is just local path. And this is where a lot of folks start their journey. However, the trend that we're seeing starting to change now is that, firstly, in the deployment and the configuration management side, people are using layering. They're starting to create different variations and permutations of their YAML, so that, for example, in one environment, they might have different properties that are being injected. They'll be hooking this up to the CI/CD. They might be putting GitOps in play with this, so that when there are changes merged in, that workload is automatically updated. So I think it's fair to say that end users are becoming natives to this environment, and they're treating this as their everyday driver for their workloads. The second really interesting thing that we're seeing is that people are going beyond this to start to integrate all of their existing technologies into Kubernetes as the lowest common denominator. So what I mean by that is folks are considering moving MongoDB off of VMs and into K8s, etcd off of VMs into K8s, and so on and so forth. This is because of the scheduling, the self-healing, and many, many other scaling and other wonderful benefits from using Kubernetes. Again, in this simple illustration, we can see that a small company might extend from running that single workload in a Kubernetes cluster to now running multiple Kubernetes clusters that are interacting with each other. There might be business units that are split across K8s clusters. And this is where we're starting to, again, see this evolution in the way that people are thinking about working with K8s. Now, upstream Kubernetes hasn't been ignorant to this fact. The upstream maintainers are very cognizant that folks are trying to solve stuff sometimes when the API doesn't exist. Sometimes they're trying to work outside of the primitives that are in K8s. And that's why, as I said at the beginning, the API definition is updated and evolving constantly. One of the more recent changes in the past few years has been the mainlining of interoperability mechanisms. So you have service mesh interface, container networking interface, container storage interface. These are all API interfaces, promises, and they can be implemented under the hood. So I don't need to write that custom definition to talk to my SAN or my NAS. I don't need to write that custom bit of code in my container that mounts a socket directly to talk to my NIC under my node. It's all now put within a ubiquitous and consolidated API that anybody can use anywhere. And so in that same theme, as users are expanding, as the API is becoming more adaptive to their needs, we're also seeing that the solution domains are changing as well. Typically, you would see a hard line between on-prem and cloud, and hybrid was something people thought about, but it didn't really work very well. Hybrid cloud usually meant you'd have some slow interoperability between the clouds, whether you'd have a BGP connect between the on-prem and off-prem. But now it's starting to shift into a much more mature system where hybrid cloud can potentially mean that you're running some of your workloads in the public cloud and then returning those workloads back to your data center. Again, here we're showing a few different variations on that, where edge compute is now extremely interesting. Micro-K8s in particular is one of these squishy little Kubernetes distributions that can get into any of those nooks and cracks on a Raspberry Pi or something else like an IoT device. That makes it very appealing to run workloads everywhere. And if you take a step back again and think about why is that appealing, again, I write something once. My WordPress page, I can write once and I can run it in my private cloud just as easily as I might run it on my Raspberry Pi. No changes necessary, just changing the target of that deployment. And so really, we're trying to make something that is a panacea for configuration and deployment, and also the operational side of things. You will see, though, here, something interesting has occurred. This dotted line around this rectangle is the operations envelope of how much toil is required to maintain these systems. And what I mean by that is anything that's not a managed API and anything that is within your deployment volume will also have an operational overhead. So maintaining multiple clusters of Kubernetes means that you need to have updates going to them. If you're using something like kubeadm, that's a fire and forget, right? You've then got K8s. What happens if it goes stale and you go out of versions? We try to solve this with things like the charmed K8s and micro K8s snap delivery system, which gives you auto updates. And so you can see that folks like us are fixing and thinking about solving that problem. But that's just one of the many different problems that you'd have if you're running a large-scale infrastructure solution. You also then need to think about, how do you grow storage dynamically? How do you configure network routing from the K8s layer down into the virtualized substrate? And that's where we see a lot of SDNs are now moving into Kubernetes. So it becomes increasingly more complex, not in a linear way, but almost factorially more complex the more cloud domains you bring in, or the more solution domains you bring in. So tackling that growing complexity really is now the key challenge. And that's really what a lot of folks are turning their attention to. We see that operators are becoming incredibly important in the space of being able to manage those large digital estates. 90% of organizations are managing their leveraging cloud services, which is an interesting and telling number. And the reason that's so high is because people do not inherently want to deal with that complexity. I would rather pay a few dollars a month for somebody else to manage S3 than to have to run it in my cluster. Think about the resilience, the recovery, the replication, and the rotor for on-call. Whereas those few dollars are spent on doing that at the economy of scale of Amazon. However, of course, that doesn't scale as my business starts to grow. And that's where cloud services often lock people in, is that you become so entrenched in using them, it is not possible to move to another solution in any cheap way. As I mentioned a moment ago with the rise of operators, I wanted to give a little nod to two of some of the most popular operator frameworks. We have KubeBuilder, which runs controller managers for many operators, and we have Juju, which is the powerhouse behind how we do the operators here at Canonical. You can see that the community engagement has been growing steadily over time for both of these, as the interest has gone from an emergent theoretical field to more an established and mature field of folks now writing components with operators. So when I go to write a database solution, perhaps, or some sort of distributed microservice that needs to have some logic around which microservice was at which position in a GUI, people turn to operators now to manage that complexity. Just as much, operators are also being used to control menial cluster tasks such as cron jobs. They will spawn jobs, which are Kubernetes native primitives, and they will clean up bits of the cluster. They will reduce the registries. We're even seeing operators, especially in the Juju machine charm and Kubernetes charm world, managing the underlying VMs within the cluster. And that could be physical compute as well, especially in the case of MAS. And they might want to prune Docker images. A node can lose a lot of disk space because of Docker images, and an operator can do that. We no longer have to inject into the cron tab on our host OS. So what we're really now discovering is that full lifecycle management is the big question mark around complexity. Having full lifecycle management is incredibly challenging when you're dealing with a variety of solution domains, so public cloud, private cloud, data center, a variety of infrastructure substrates, bare metal, virtualization, emulation, edge, IoT, and then you have a challenge of then applications on top of those, whether they're running as native applications that have been deployed through Ansible, through Terraform, through Juju, through some other system. And so therefore, full lifecycle management is really something that we need to start thinking about in its entirety, not just at a cluster level. And again, this is where, as I said, we've been doing a lot of research with Juju to try and effectively manage the machines and the applications on those machines and the cluster, because otherwise it quite simply is going to grow out of hand. Imagine if this small example was in a large bank and you'd have several hundred of these elements all stitched together, and then you have to think about networking considerations, authority, regional access, auditing, all of those things that make this a really difficult challenge to solve. One of the things that I mentioned at the beginning was talking about this idea of trends and where we're seeing things going. Complexity seems like something that's fairly binary in terms of, as complexity rises, yes, it makes sense to automate much of that process. However, another thing that is also emerging is now hyper-specialization. As more industries and more markets open up to using K8s as their substrate, they're now thinking, how do we take everything we've got and push it into Kubernetes? Now, it doesn't sound very wise doing that, does it? And that's not always the case, because sometimes it is simply just a lift and shift. However, if I was to run my own telco, it makes sense that I would probably need some special requirements. I would probably be penalized if I didn't meet a certain latency on transmission of traffic, especially when you think about telcos doing a lot of baseband processing. They require super accelerated hardware. And just to exemplify this, there is now a widespread of industrial demands being placed on Kubernetes. We talked about telco, but let's move from right to left here. Fintech is in the same vein that they need low latency, but they have high regulatory requirements. Even folks looking at the logs in production will need redactions on those logs. There are some APIs and cloud vendors available to do such a thing. However, that's not ubiquitous. Just because we can schedule something into a different Kubernetes cluster doesn't mean that redaction API is going to work across all the clouds. Energy, manufacturing, they have considerable attack surface from foreign bodies who might want to cause any form of industrial espionage. So therefore, we also need to have high security controls. We also think about things like signing of images to make sure there's been nothing injected that's malicious. And finally, on the left part of the scale, gaming and entertainment. Gaming has two different axes here. You have the data center side, where you're performing computations in a networked environment to produce results or updates to a multitude of players. Then you've also got the distributed edge, where you might be running a GPU locally to the player to offload those calculations to render something on the screen. Additionally, entertainment with stream shaping. It's not standard Kubernetes technology that you'd be employing here. You'd be using hardware to enable that stream shaping. And there is a gap. Kubernetes doesn't know about all hardware. It assumes that it's running on a kubelet somewhere that can fetch the basic capabilities. It doesn't really have this cognizance of its contextual surroundings, which is a really interesting place that people are starting to build. I apologize. Looks like we've gone to the wrong slide there. So, network and GPU offloading, infrastructure substrate, and certifications. These are the three things in hyper-specialization that are emerging as hot demands from end users and companies who are implementing Kubernetes as a platform, as a service, as a solution. Network offloading and GPU offloading, I spoke about it a little bit a moment ago. This idea that if you want to perform a really fast computation, I'm not going to render Grand Theft Auto on my CPU. I'm going to offload it to my NVIDIA card, which is designed to handle those kind of calculations at speed, given the many, many GPUs that it's furnished with. Equally, network offloading, I want to be able to leverage a super fast NIC that's attached to my physical machine or my VM that then goes through an optimized switch. These two pieces alone make up a significant change in the direction of where end users are pushing Kubernetes. And what we're seeing as well is that vendors, infrastructure vendors, are starting to build the hardware, write the firmware, write the software, and not call it job done anymore. They're then also writing now as standard an operator that goes in Kubernetes to leverage their software. So they are then pulling their software primitives up into Kubernetes as a standard substrate. They're no longer just leaving you with a device driver on the host OS. And so they have realized that K8s is becoming the lowest common denominator. Equally, infrastructure substrate is incredibly important here. We see that people no longer are happy with just running in somebody else's cloud. They may want to leverage their data center, and they may want to leverage it because of the former point. The idea that they might have 5,000 nodes with GPUs. They might have 5,000 nodes with accelerated networking capabilities, or even they might have the ability to have vCPUs with some additional capacity that you couldn't get as cheap in the cloud. So having infrastructure substrate agnosticism in the same vein as POSIX, as I mentioned earlier on, is something that is in hot demand. This basically means Kubernetes really does need to run anywhere, from the edge to the DPU. And finally, certifications. This one sounds maybe more innocuous, but is just as important as the two prior. We're seeing that things like SOC 2, things like FIPS, things like CIS, and also galvanizing against things like MITRE, things like the NSA profile for attacks, are becoming incredibly important in achieving security and building trust that Kubernetes run in any of these substrates is worthy of putting our business on top of. And so a lot of effort is being done within not only communities, but vendors to certify different types of Kubernetes distributions on their hardware and to make sure that it provides the same experience across the entire solution domains. To look a little bit more at the specialization I just mentioned with networking and GPU offloading, the illustration on the left gives a very quick example of how virtualizing network components is now being done at the Kubernetes level. This is really interesting because we can now define switches and routers as primitives and have workload pods emulating them. You might have a pod that's acting as a router, and we modify that pod's IP table rules underneath on the host to emulate a switch and forward our traffic. Equally on the right, we're seeing that not only are we wanting to use GPU drivers inside of our pods, but we also might want to be able to use vGPUs. There is an increasing usage and thirst for multi-tenancy in Kubernetes, and so we're now applying GPUs with virtualization inside pods so that we can create multi-tenant game environments. And these things are both real use cases of folks who are working to solve these complex problems out in the wild. As mentioned, the infrastructure substrate in these bullet points kind of succinctly puts what I was talking about a moment ago. They're targeting specific substrates as well as wanting them to work everywhere. We need to start thinking about how can data centers on Metal be brought to use Kubernetes directly. And for example, this is a big play with Maz and K8s. We see there's a real demand for running bare metal underneath Kubernetes. People don't want to have a management layer in between that. And finally, as I mentioned, edge processing units such as the gaming offloading on the edge is becoming increasingly popular. And we're seeing that Ubuntu core is being more and more in that conversation and through demand. And just in review, NCSC, SOC 2, FIPS are now some of the things that are just expected of any notable Kubernetes certification. They're not easy to do though. They rely on you owning the full stack. We're starting to see that there's a trend towards signing of images, signing of packages. We're looking at things like how do we ensure the life cycle of an asset all the way through to the workload deployment, and how do we then measure that that is being unfettered along that journey. So this specialization is really being grown out of a lot of the work being done in the technical advisory group for security, a lot of vendors who are trying to productize this journey as well. And so finally, with all that said, I suppose it leaves us some key opportunities here. But there is a challenge. Choice is the problem, in the immortal words of Morpheus. I think that the issue is here, you have so many providers, so many vendors, and so many projects all swimming in the same sea and creating a lot of noise. There is a real difficulty in knowing how to implement things. Let's say that I was asked to put something on X cloud provider as a cluster, make sure it's all completely automated, updates. I think, okay, I use an operator. And then someone comes along and says, oh yeah, and the host operating system has to update too. Suddenly I think, oh, damn, well, I'd have to do some research and I'd find some other thing that I can cobble together. So then perhaps I have two operators that are running from two different projects, but they don't quite work very well together. So I then build some custom architecture to manage the two operators that manage the cluster, that manage the host OS. And it becomes a little complex. In conjunction with that, we're also seeing that cloud providers don't necessarily want to make this stuff easy. It is possible for a provider to give you a graph of all of your assets, right? From the VPC all the way down to your compute node, looking at the leaf and node of storage and everything in your cloud, and to have almost like an effect of a puppet pulling it up and down. You can scale it up and down, you can manage it. But the direction that cloud providers are often going more into is scaling. It is incentivizing you to build more to solve your problems. So it's like digging a trench, and then the dirt goes in behind you, and the trench keeps, you don't get any further into the ground, because they're effectively creating this loop where you are growing your infrastructure to manage your infrastructure, to grow your infrastructure, to manage your infrastructure. And there is an aversion to this by a lot of the community now, who are looking to those cross-cloud solutions and are looking to something to manage this for them, because it's complicated. End users want to build solutions in Kubernetes and leverage hardware accelerators. And this very much is still an expensive, it is still somewhat theoretical for some of the acceleration. GPU is well established. Network is harder, because if a large cloud provider wanted to offer you any type of network acceleration, they would have to have any type of network acceleration in every data center. And there's not a lot of cost effectiveness for them to have that sat there unless it's being utilized. And so therefore, when you look at those drop downs for the type of machines you can have, the type of NICs you can have attached, the networking infrastructure, it's all very much on rails. And that might not necessarily suit your business experience. So how are we thinking about it? Well, we have some very interesting products. And I've just picked an example here. What I like actually is that we have this interoperability. You can use OpenStack and Charmed K8s, OpenStack and MicroK8s, MAS and MicroK8s, etc. In this example here, we're using MAS, so Metal as a Service, provisioning nodes. But those nodes with MAS are provisioned in a data center that has certain properties on those nodes, certain labels. For example, they might have smart NICs on that particular above that tier top of rack, and then you've got a smart NIC, and that network substrate is earmarked to say this is an accelerated network substrate. You might have two racks that are have an InfiniBand between them for some sort of high availability. And so MAS is a really nice way of being able to provision, and then we run Charmed K8s on top of it. Now, the secret sauce here is that it's not a two-step process. With the Juju operator control plane, it's deploying MAS, it's running the data center side of things, it's then deploying Charmed K8s. But it doesn't stop there, right? Because then on top of Charmed K8s, you then can provision your workloads through Juju. And then the final part of that, it's all related. So you then get this beautiful little illustration of, hey, you've got this to this to this, and you can then destroy that thing, and then destroys all this tree of dependencies. So we think of this very much from the data side of things. And I think that's where we're going to see a large landscape shift. It's going to be less about independent operators concerned with their little state of the world, more about operators potentially reporting through a common API of, these are the things I care about, these are the things I manage, these are my dependencies. And so if you are interested to look at more of how we think about that, I would recommend you check out Juju, because there's some really interesting ideas there. So just to recap, end users are now expecting to build complete solutions with Kubernetes. That's now a given. The increasing complexity, though, when they operate across clouds, ecosystems, infrastructure, and pull things into Kubernetes that aren't necessarily designed for it, becomes hard. And that's compounded by the fact that they might need then acceleration on certain elements of their digital estate for particular regulatory, commercial, or sort of cost opportunities. And then the final part of that is that operators synthesize human operators, and those are paramount to the scaling of that effort. And as I mentioned lastly, we have our own explorations into that and have had immense success through the Juju pattern. So that's all we have time for today. I'm so happy, and thank you for allowing me to present this. I would recommend that you check out juju.is, mas.is, and MicroK8s as well. We have a lot of interesting ways that our products work together, and I think you'll find them really interesting and refreshing in that you don't have to manage 50 different things. Thank you for putting up with me. Back to you, Dave.